I wanted to do a little tribute to Control because they just had their 2-year anniversary recently. And this little upside down pyramid here is the board. They run the astral plane. You should check out the game if you haven't. It's pretty fun. But yeah, I'm Novox Populi. You can find me at Novox Populi pretty much everywhere. I have the following side projects. Maybe you've seen them around. They're in various states of abandonment, in progressness, and occasional readoption. So like from left to right, you have Ember, which is end-to-end encryption. In the middle is a REPL for Markdown and Ember together, demonstrating my preferred way of writing docs. And then on the right is kind of an experiment I was doing with the Web Animation API, which is pretty cool. You should check it out. You kind of don't need an animation library anymore. So, yeah. I also want to say that I work for CrowdStrike, and CrowdStrike's always hiring, so if you're looking for a job, message me and I can send you some links, or you can just go to crowdstrike.com/careers and then poke at Workday until it gives you what you want. All right, so what is a resource? First, we got to do a brief overview of auto tracking. And as a disclaimer, I guess a disclaimer to the disclaimer. There's a scheduling issue with some maintenance on the roof. So if you can hear hammering, I'm getting my gutters replaced for some maintenance-free gutters, and I'm pretty excited about that. But anyway, back to the original disclaimer. This is a simplified or brief version of auto tracking and not entirely an accurate representation. So let's say we start with a template. This template has 2 references. And this template has a backing component class. The classic first name, last name, full name example. The first and last name are tracked, and full name is a getter that returns them both as a single string. So following the flow of execution, we see that full name from the template will call the getter on the component instance. And then, as the full name getter is evaluating, we run into a property on the component instance that we need to go look at. So first name is a tracked property, and tracked properties are also references. But because we encounter this reference while evaluating the value of another reference, we know that full name now has a dependency. So we've encountered one reference, first name, which is known to the original reference, full name. So going back to the flow of execution, we run into another property, last name. We see that last name is also a tracked property, which is also a reference. And now the template renderer is aware that the reference, this.fullName, is dependent on these 2 other references, which, to peek under the hood a little bit for a little more detail, we can kind of think that when evaluating a reference, we create a new tracking frame, which is a weak set, and the tracked decorator expands to add references to that current tracking frame via getters and setters. For a deeper dive into how auto tracking works, like it'll give you enough detail to where you can implement this yourself. You can check out Zirak's article on how auto tracking works. URL right there. So, what is a resource? It is a helper that can be used outside of templates, or a getter with persistent state and/or lifecycle. All right, so what does this mean? First, we need to ask, what problem do resources solve? So, they protect against side-effecting getters. they bridge the gap with reactive primitives provided from Ember. And they answer the question, how do I safely deal with async data? Because getters can't be async. Maybe you've tried it before, you return a promise from a getter, you see your template isn't updating as you would expect it to do. So what is a side effect? When behavior unrelated to data derivation is triggered and the result of that behavior is accessed elsewhere. And what I mean by that is this. But this has an immediate problem. Just give this code a read and see if you can find it. Right. So the template accessed this query. This query starts an async request, and that request returns an object for the records, which points to an empty array. Records was a tracked object. So the async request in the query resolves and sets this records to a new value. Since this records is a tracked object, query depends on the reference records. So you go back to the top, and then that just repeats forever. So maybe you've seen assertion message come from this problem. I think it was added in Ember 3.25, 24, somewhere around there, maybe earlier. I don't remember. But anyway, it's like you accessed blank on an object that was like accessed previously in the same rendering computation or whatever, and it's like just trying to prevent infinite revalidation bugs. So one way we can solve this is just to not access this .records in the query getter. That will avoid the infinite revalidation error. But then we need to access this query getter in the template, and it kind of just looks weird. Because this query doesn't provide any value to the display. But maybe you've seen this other pattern. Using did insert and did update to get some records, and then you add arbitrary arguments to know when to refetch those records. So problems both the getter side effect and these did insert and did update modifiers have is that they're hard to make reusable, and these types of side effects are undocumented and therefore spooky. And what I mean by undocumented is that like every occurrence of them might be slightly different, and your developers and coworkers might miss minor differences between each of the different implementations. Also, the template ultimately has no business caring about the sort of data manipulation, as it may have nothing to do with a particular element. And with both approaches, you ultimately leak state and intent everywhere. So that prevents the broad understanding of what the focus of your component or whatever your abstraction is. So I'm saying resources are going to solve that, but how do you make one? So there are 3 ways so far, and each of these has different trade-offs, but that's a discussion for another time. But in this imaginary scenario, and I say imaginary because neither of these libraries provide a query resource. But let's say we're using a resource that abstracts the async behavior and various states you would expect from Ember Data's store.query. So you'd expect it to have results, error handling, loading status, stuff like that. And you may be asking yourself, but if it does that, that seems like it has a lot of overlap with Ember concurrency. Why would I use a resource over Ember concurrency? And that is a great question. The answer is that resources are lazy, and they don't do anything until they are accessed. So to demystify how that works, let's roll our own resource implementation and ignore both of these libraries. So minor details aside, and maybe major details depending on how you look at it, this is the entirety of what an inline resource with no abstraction would look like. So this is the part that is abstracted away by the two previously mentioned add-ons, Ember Could Get Used to This and Ember Resources. And this is the user land stuff, closer to what you saw in the examples earlier. And maybe you're thinking, this getter approach looks an awful lot like the getter side effect a few slides back. And you'd be right. You're paying attention. This is a side effecting as well as imperative, just like the other examples. But we can do better. So why use resources at all? A resource will abstract the side effects and imperative nature of async data handling so that an app dev can focus on the declarative side of data derivation. Additionally, resources have all these benefits listed here. And most importantly, all of these things fill the gaps left over from the old paradigm of Ember Classic when we all switched over to Octane. So in most cases, you aren't going to be writing your own resource implementation from scratch. So sticking with our query example, let's look at what creating a resource using one of the two previous libraries looks like. Now, when deciding on implementation, regardless of what it is, I like to start from the outside in. What do I imagine the easiest to use public API for the function, class, or add-on is that I'm about to make? So in the top left, we can go the Ember Resources approach and provide a single export to use query. In the bottom right, we could go the Ember Could Get Used to This approach, which requires 2 imports. And personally, I like the look of this better, even though it's the same number of key presses if you exclude the decorator. It's just something about the new keyword, but I don't know. If you have a preference over which you like, let me know. I'm interested in that kind of thing. So I'm going to be showing you how to implement a query resource using Ember Resources for a couple reasons. I wrote and maintain Ember Resources, so I can provide better support for folks that have questions. And the query resource already exists in the Ember Data Resources package. So if you're interested, you can reference that for a fuller implementation. So over on the right, we have what might look like a resource implementation. Of note, this is all we get for a lifecycle hook. Oh, but what about handling destruction, you might be thinking? Well, we can use @EmberDestroyable, where we can have setup in the body of the constructor, and any tracked data accessed here will entangle with the caller. We have update here, conditional code in the body of the constructor, so any tracked data in here will also entangle with the caller. And lastly, we have destruction or teardown provided by EmberDestroyable. And what I personally really like about register destructor is that you can co-locate setup and teardown, which means you pretty much never need framework provided teardown hooks ever again, which is very exciting. So where were we? This is where all lifecycle happens in the constructor. And this is the bulk of our resource, the start method. When this method runs, it will set the request lifecycle you would expect from an async abstraction, is loading, error, etc. Of note, this part here exists so we can disconnect from an active tracking frame, which allows us to set tracked data without running into the infinite revalidation assertion. So everything above this await promise resolve is entangled with the call site, and everything below won't affect the rendering or trigger that assertion. So over here, we have a little helper function. This is optional, but it is a nice way to provide only one import to the call site instead of 2. Instead of importing both use resource and the resource itself, folks can import this one query function instead. This also has the added benefit of allowing you to customize how the args are passed to your resource. For example, in this case, model name is passed directly to the query rather than part of the thunk function. This opts the model name out of reactivity because only arguments accessed within the thunk function will reactively entangle with the call site. But let's say you don't want to worry about that. What's the bare minimum you can do while still having one import at the call site? And how will that affect the API at the call site? So you could use this one-liner, but it means you widen the API at the call site, which could potentially confuse users. They might be thinking, what is positional? What is named? Why do I care? And that's why I prefer abstracting them. Right, so if you're curious about what the real thing looks like, feel free to take a look at Ember Data Resources on GitHub. So what else could be done with resources? So Ember Array Map resource is like array.map, but you can reassign array references, which are records in this case, and the transform you apply will only be applied to the added or updated records using object identity to track equality. Most of the utility comes from expensive transforms where you don't want to be rerunning the transform on every array element every time the array changes. So you can just reassign records willy-nilly, and the transform only runs on what's changed. So maybe you want to do a headless UI implementation. So here's an example here of maybe how you would manage a table, and then you can hook up your own DOM to it. Maybe WebSockets. I like this approach because I often feel like using a service for WebSockets isn't sufficient because sometimes I want multiple connections on the same socket on the page, and since services are singletons, it can get a little tricky to do that. But yeah, ideas welcome. If you have an idea, I'd like to hear it. Resources are new and still ripe for exploration. Thank you. Here are some resources for resources.